Hello, my name is Jenny Liontou. I work for the Greek Ministry of Education, and it's with great pleasure that I'm taking part in today's conference. Our presentation today will focus on computational linguistics and English language instruction, and we're going to talk about an approach to automatic text classification. Thank you so much for the invitation. I hope you will enjoy the presentation, and I'm always available for your questions. We can now move on to a brief outline of today's presentation, which will focus on the literature review section. The aim of the research will be presented along with the research questions. The methodology followed for the present research will be clearly explained, and then findings from the present research will be discussed along with concluding remarks that can be useful to language teachers and material developers and test designers regarding English language instruction. So, although the issue of text readability is long-standing and has a rich research tradition, its impact on foreign language assessment has garnered increased attention over the last decade, while the number of studies on exam validity and reliability has also increased. Providing test takers with texts that are too difficult or too easy to process can affect their performance and contaminate test results. So, defining text complexity is critical for test developers to become aware of the range of factors that makes texts more or less accessible in order to be able to select reading texts at appropriate levels for inclusion into the reading subtests of their examinations. Having said that, the Common European Framework of Reference for Languages has nevertheless failed to provide any specific guidance as to the topics that might be more or less suitable at any level of language ability, or define text difficulty in terms of text length, content, lexical or syntactic complexity. In fact, in a rather recent study, in 2004, Alderson et al. Discussed the difficulties that arise in interpreting the CEF because it does not contain any guidance, even at a general level, of what might be simple in terms of structure, lexis, or any other linguistic level. So, the EFL language teachers and test designers have to decide on their own and based on their own intuition whether a text is appropriate in terms of difficulty for their intended audience. A long time ago, Alderson and Joguhert underlined the fact that the literature on reading abounds with speculations, opinions, and claims, especially in foreign language reading, but relatively little evidence is brought to support specific issues. In other words, there is still lack of adequate documentation on how the difficulty level of reading texts is determined and on the claimed processes applied for text selection. The aim of the present research was to delineate and compare a range of linguistic features present in the Greek State Certificate of English Language exams at two different levels of language competence, intermediate and advanced reading texts, in order to better describe linguistic differences across these two levels and in fact explore their contribution to text complexity. So the research question that was formed was whether there are any statistically significant differences between B2 and C1 reading texts with regard to specific lexicogrammatical features. The Greek State Certificate of English Language Proficiency exams is a new suite of exams administered by the Greek Ministry of Education. Exams take place twice a year throughout Greece, and the level of competence ranges from A1 beginners up to C2 proficient users. The data used in the present research consist of 180 reading texts, mainly narrative ones according to the Ph.D. classification. To avoid any text length effect on text indices, the length of all texts was controlled to 250 words. The topic of text was mainly of a general interest, and the texts were drawn from magazines, newspapers and leaflets. So let us move on to the text processing tools used in the present study. Over the last 10 years, advances in computational linguistics and machine learning systems have made it possible to go beyond surface text components and adopt more theoretically sound approaches to text readability, focusing on a wider range of deep text features that take into account semantic interpretation and the construction of mental models, and can thus offer a principled means for test providers and test takers alike to assess this aspect of test construct validity. In the present study, Cometrics 2.1 and 3, Linguistic Inquiry and Word Account 2007, Vocabulary Profile 3, Computerized Language Analysis Suite of Programs, Computerized Propositional Idea Density Rater, Spider, Granulator, and Text Analyzer, along with Wordsmith tools, were used to estimate 135 text variables. To begin with, a great extent of the present study was based on Cometrics, a freely available web-based tool developed at the Institute of Intelligent Systems of the University of Memphis that uses lexicons, parts of speech classifiers, and statistical representations of word knowledge to measure cohesion and text difficulty at deeper language levels. According to its creators, Cometrics is an improvement over conventional readability measures because it succeeds in examining deeper linguistic text features such as semantic components and word sense associations, and eventually matches this textual information to the background knowledge of the reader. Web Vocabulary Profile 4 and its updated M.Sc version 3.2 are two more freeware available web-based vocabulary profile programs which were used to estimate word frequency and obtain lists of word tokens, the total number of running words in its text, word types, and word families for its text in our corpus. Based on nations' frequency lists, Vocabulary Profile classifies the vocabulary of a text into frequency levels and outputs a profile that describes the lexical content of the text in terms of frequency bands by showing how much coverage of the text each of the 20 lists accounts for. Propositional idea density was estimated using the computerized Propositional Idea Density Rater, a computer program that determines the propositional idea density of an English text on the basis of part of speech tags. Developed at the Institute for Artificial Intelligence of the University of Georgia, the computerized Propositional Idea Density Rater is a user-friendly Windows application distributed as open source freeware. Following Kinch's theory of comprehension and the representation of meaning in memory, Spider 3 functions based on the item that propositions correspond roughly to verbs, adjectives, adverbs, prepositions, and conjunctions. In order to assess lexical diversity, Malvern and Richard's D formula, incorporated into the VOCD command of the computerized language analysis suite of programs, was used. A minimum sample of 50 words is required for VOCD to compute a value D, a measurement based on the analysis of the probability of new vocabulary being introduced into longer and longer samples of speech or writing. According to its designers, D presents methodological advantages over other measures of lexical diversity because it is independent of sample size and makes it possible to perform valid comparisons between varying quantities of linguistic data. Jarvis, in 2002, compared the accuracy of 5 commonly used formulas of lexical diversity in terms of their ability to model the type-talking curves of short text, and found that D provided more accurate curve fitting models. However, it is worth noting at this point there are fewer studies that have used D in applied educational linguistics, where VOCD originated from, than in other language-related research areas. This could be attributed to the fact that quantitative measures of lexical diversity like D are not able to capture what lexical items are actually used and how. In addition, D was recently criticized by McCarthy and Jarvis for being sensitive to text length variation. McCarthy and Jarvis concluded their research in 2007 by questioning whether a single index has the capacity to encompass the whole construct of lexical diversity, and urged researchers to select those measures that had proved more effective than others over particular lengths of texts. More recently, McCarthy and Jarvis presented a new index of lexical diversity called the Measure of Textual Lexical Diversity, MTLD, which is calculated as the mean length of word strings that maintain a criterion level of lexical variation in a text and does not appear to vary as a function of text length. Once again, McCarthy and Jarvis concluded their study by advising researchers to consider using not one, but 3 specific indices, namely the MTLD, the VOCD value, and mass index. Thus, in the present research, all 3 indices were estimated over all available reading comprehension texts, while their impact on text readability was further explored through correlational analysis. In addition to CLAN, the Linguistic Inquiry and Word Count 2007 analysis program developed by Francis and Penbaker at the University of Texas was used. This software can be used to count words in psychologically meaningful categories based on a specially designed dictionary of 4,500 words that is divided into subsections according to the category they define. LIWC 2007 made it possible to estimate the percent of word units that express the variety of psychological processes, such as cognitive, affective, social, and perceptual ones, and further explore their impact on text readability. This part of the research should be best viewed as a springboard for an analysis of text features that may affect comprehension in a more subtle way and whose effect on exam performance has today been largely ignored. Moving on to describing briefly the descriptive indices used in the present study, we can start by defining the number of words in a text, in our case 250 words, but also the number of different words in a text, in other words types, the mean of the word families, the mean of syllables per word, characters per word, and words per sentence, along with number of sentences, number of paragraphs, and sentences per paragraph. A number of different readability and disability indices were also estimated. First of all, the flash reading ease index was used, the Flesch-Kinghart grade level index, the Dalschall grade level index, the sparse grade level index, the Cummings-Fogg index, the Frye readability graph. All these readability indices were actually used because there's no agreement to the present day regarding which one could be considered as more reliable than others. In addition, syntactic simplicity, word concreteness, the deep cohesion of sentences, verb cohesion and connectivity were estimated through a cone matrix. Word frequency has been found to be an important factor of text complexity. So, in the present study, all frequency bands up to 10,000 words of the M.Sc corpus were estimated. So, words belonging to the first 1,000 more frequent words of the M.Sc corpus were estimated, along with K2 words, K3, K4, and so forth up to K10 words. Academic word list estimation was based on Coxhead's famous list, and it is important to see whether our texts contained a higher percentage of academic words or more general ones. Regarding lexical richness, VOCD was estimated along with MTLD and mass. Moreover, the percentage of tokens per family and types per family was defined along with words once mentioned in the text, apax legomena, or mentioned twice in the text, relative text entropy, lexical density, the frequency of content words along with the frequency of all words, and the minimum word frequency per sentence. Hypernym measures are also indicative of text abstractness, since a word with more hypernym levels invokes more word association and is thus more concrete and easier for English language learners to acquire, whereas a word with fewer hypernym levels is more abstract and thus expected to be more difficult to decode. Employing WordNet, an online lexicon that has been used in a variety of studies on word sense, disambiguation, and conceptual density, and whose design is inspired by current psycholinguistic theories of human lexical relations, Cometrics provides mean hypernym values, that is the number of levels a word has in a conceptual taxonomic hierarchy for all the nouns and main verbs in a text. Moreover, polysemy refers to the number of senses, in other words, core meanings of a word. For example, the word bank has at least two senses, one referring to a building or institution for depositing money, and the other referring to the side of the river. Cometrics provides average polysemy for content words in a text. Polysemy relations in WordNet are based on synsets, as we call them, groups of related lexical items, which are used to represent similar concepts but distinguish between synonyms and word senses. These synsets allow for the differentiation of senses and provide the basis for examining the number of senses associated with a word. Cometrics reports the mean WordNet polysemy values for all content words in a text. Word polysemy is important because it is considered to be indicative of text ambiguity. In other words, the more senses a word contains, the more difficult it can be its interpretation. However, more frequent words also tend to have more meanings, and so higher values of polysemy in a text may be reflective of the presence of higher frequency words. Cometrics also contains a number of indices on text abstractness, which are actually based on the Medical Research Council Psycholinguistic Database. This database, M.Sc is called actually, contains more than 1,500 words and provides information on various linguistic properties of these words based on experiments conducted by different researchers who used human subjects to rate large collections of words for their psychological properties. However, unlike other electronic dictionaries, the M.Sc Psycholinguistic Database does not provide any semantic information about the words it contains. Nevertheless, its indices are considered important for L2 lexical networks because they can measure the extent to which words associate with each other. Cometrics can help us estimate the concreteness of content words, that is, the mean concreteness value of all content words in a text that match a word in the M.Sc database, and the minimum concreteness of content words, which is the mean score of low concreteness words across sentences. Both indices measure how concrete a word is on a scale ranging from 100 to 700, with high numbers showing increased concreteness and low numbers indicating text abstractness. Content words matchability is an index of how easy it is to construct a mental image of the word. It is also provided in the merged ratings of the M.Sc database. Cometrics provides the average ratings for content words in a text. For example, low imagery words are risen or compared to words like with high imagery like hammer, bracelet. Content word familiarity refers to how familiar a word seems to an adult. Sentences with more familiar words are words that are processed more quickly. M.Sc provides rating for 3,488 unique words, so Cometrics provides the average ratings for content words in a text. Raters for familiarity provided ratings using a 7-point scale, with 1 being assigned to words that they had never seen before and 7 to words that they had seen very often, nearly every day. Words with very high familiarity include mother and water, compared to dogma and corner. Content word age of acquisition is another index that includes the age of acquisition norms from M.Sc database. Age of acquisition reflects the notion that some words appear in children's language earlier than others. Words such as matrix, for example, have higher age of acquisition scores than words such as milk or smile or pony. Words with higher age of acquisition scores denote spoken words that are learned later by children. Cometrics also provides the average ratings for content words in a text. An example of meaningful word is people as compared to others, for example. Words with high meaningfulness scores are highly associated with other words, whereas a low meaningfulness score indicates that the word is weakly associated with other words. Average LSA sentence givens refers to the average giveness of each sentence. Finally, latent semantic analysis is an important method of computing semantic or conceptual similarity between sentences. LSA is a statistical technique for representing word knowledge based on a large corpus of texts. More specifically, LSA condenses a very large corpus of texts to 100 to 500 functional dimensions, which represent how often a word occurs within a document, defined at the sentence level, the paragraph level, or in larger sections of text. This way, each word, sentence, or text ends up being a weighted vector according to which the conceptual similarity between any two text excerpts is evaluated. As Crossley and McNamara explained, unlike lexical markers, of co-referentiality, LSA provides for the tracking of words that are semantically similar but may not be related morphologically. In cometrics, the sentences, paragraphs, and entire texts are represented by LSA vectors based on a specific set of dimensions. In fact, cometrics reports mean LSA values ranging from -1 to 1 for all sentence combinations in a text. Several studies have used LSA to measure differences in text cohesion and essay grading, as well as the development of lexical networks in L2 learners, but its usefulness in the context of foreign language teaching and testing remains greatly unexplored. Thus, the present research is regarded to enjoy a sense of novelty by exploring the contribution of LSA indices to the grading of English reading texts within and across two levels of language competence. Regarding syntactic complexity, higher level constituents were estimated along with modifiers per noun phrase, words before main verb, the average noun phrases per text, along with verb phrases, adverbs, and negations, passive voice forms, and syntactic structure similarity across all sentences and between adjacent ones. Propositional density was also estimated using Spider. As far as cohesion is concerned, referential cohesion, causal cohesion and causal content, intentional cohesion and intentional content, temporal cohesion, spatial cohesion, logical operators and conditional operators were estimated using core metrics. Global overlap considers the overlap of each sentence with every other sentence in a text, whereas local noun overlap represents the average number of sentences in the text that have noun overlap from one sentence back to the previous one. Argument overlap occurs when there is overlap between a noun in one sentence and the same noun in another sentence. It also occurs when there are matching personal pronouns between two sentences. The term argument is used here in a linguistic sense when noun and pronoun arguments are contrasted with verb and adjective predicates. Global and local stem overlap measure noun constraints held by the noun and argument overlap measures. A noun in one sentence is matched with a content word in a previous sentence that shares a common lemma. Global and local content word overlap measures the proportion of explicit content words that overlap between sentences. For example, if a sentence pair has fewer words and two words overlap, the proportion is greater than if a pair has many words and two words on the overlap. Global and local anaphor overlap includes the anaphor overlap between pairs of sentences. A pair of sentences has an anaphor overlap if the larger sentence contains a pronoun that refers to a pronoun or noun in the earlier sentence. Since connectives have also been found to affect text complexity, Cometrics provides indices for all connectives present in a text and further defines them in terms of positive connectives, negative connectives, additive connectives, temporal ones, causal connectives, logical ones, and contrastive connectives. Text analysis further focused on the percentage of gerunds, infinitives, nouns, verbs, adjectives, adverbs, personal pronouns, first person singular pronouns and plural ones, second person pronouns, third person singular and plural pronouns in a text. Finally, the percentage of idioms and phrasal verbs in a text was estimated along with that of question marks, past, present and future tenses, auxiliary verbs, prepositions, numbers, articles. Using LIWC 2007, the final stage of this research included an estimation of the psycholinguistic processes that could be presented in our texts through affective processes, positive emotions and negative emotions represented in a text, the cognitive mechanisms that included tentative words, words of certainty, words expressing agreement, words expressing insight, discrepancy words, and causal ones. Our final set of analyses included the percentage of words expressing senses related to social issues, friends, family, school, job, leisure, body, and money. When looking at the results of our independent samples t-test between intermediate and advanced EFL reading comprehension texts, we can see in blue features present in intermediate texts, whereas in red we can see those features that characterize advanced reading texts. To be more specific, advanced reading texts had a higher percentage of words per sentence. In other words, they consisted of longer sentences. They also consisted of longer words in terms of syllables per word and letters per word. They were more complex in their structure since they contained more words before the main verb and more modifiers per noun phrase, and a higher density of noun phrases. On the other hand, intermediate texts were simpler in terms of their syntax and in terms of their verb phrase density. Moving on to our next slide, we can still see that advanced texts had a higher percentage of bellissimous words, a lower percentage of familiar words, and a higher percentage of less frequent words, as those appearing in the second band, third, fourth, and fifth of the B&C corpus, the same for words included in the sixth up to the 10th B&C band. On the other hand, intermediate texts consisted of more concrete words and a higher percentage of frequent words in the B&C corpus and in the SELEX database. Our final set of analyses indicated that intermediate texts had a higher frequency of tokens per family and more present tenses, whereas advanced texts were more dense in terms of lexical density. They had a higher percentage of families. They also consisted of more academic words and more prepositional phrases. The results of our analysis could help us better define the statistically significant differences in terms of lexical features between intermediate and advanced texts. If we try to create some text classification questions for our teachers to be more aware when choosing texts for their EFL learners, we could have, for example, a question regarding word frequency. In other words, how frequent is the vocabulary of the text we are about to use? How abstract is the vocabulary of these texts? How diverse, in terms of lexical diversity, is the vocabulary? How complex is the sentence structure, and how complex is the overall text structure? The ultimate purpose of the present research was the creation of the mathematical formula that could make possible the automatic classification of English texts to two levels of language competence, that is, intermediate or advanced ones, according to their complexity level. In order to avoid contamination of results due to text length variation, the frequency counts of all linguistic features were normalized to a text length of 100 words. IBM SPSS 20 statistical package data was used to compute descriptive statistics and perform reliability analysis. In order to create our statistical model, regression analysis, a procedure commonly employed for predictive purposes, was used. Due to the high number of independent text variables and the two levels of text classification, binary logistic regression was carried out using the forward method and the Wald criterion in IBM SPSS 20. Following this method, the program entered in the analysis one variable at a time, depending on whether it met a predefined set of statistical criteria, and also removed those that contributed less to the predictive power of the model. To avoid overfitting our model, a minimum of 15 cases of data for each predictor variable was considered acceptable, with a final model containing 4 predictor variables. Based on this model, the resulting regression equation, which is presented in your conference today, or prediction formula, which may be called the LST Text Difficulty Index, is as you can see in the slide. The 4 variables which were found to contribute significantly to text classification are lexical density, academic word list, syntactic similarity across all sentences, and the percentage of tokens per family. When adding specific numeric values to the predictor variables, the binary logistic equation can provide us with a score that ranges from 0 to 1. Given that in our analysis the categorical classification of the dependent variable was 0 for intermediate texts and 1 for advanced texts, scores higher than 0.5 designate the probability of a text being classified as an advanced one, whereas scores lower than 0.5 refer to the possibility of having an intermediate text. The formula does not only provide us with a predicted difficulty level of a given text, but also makes possible the comparison of text scores within the same level of language competence. In other words, if we accept decimal places in the final score, we could achieve an even higher consistency in our selection of similar level texts by defining the range of values that is considered most appropriate for a specific learning condition. The formula can be implemented in any computer program that includes basic mathematical tools, such as Microsoft Excel, for interested users to insert appropriate values and to automatically obtain a rough text difficulty score in relation to these two levels, intermediate or advanced ones. It's important to note at this stage that when tested against human raters classification of 120 new texts, LAST, Text Difficulty Index, showed a 95% of agreement between subjective judgment and objective automatic measurement. This means that the new algorithm can prove useful to EFL teachers, material developers and test designers interested in automatic text classification, and should be best viewed as a springboard for more theoretically sound and practically useful natural language processing and intelligent information retrieval tools to be developed in association with English language teaching, learning, and of course, assessment. I need to thank you all so much for your attention. It has been a rather long and sophisticated presentation. Hope you've enjoyed it. It has been an honor and pleasure taking part in your conference, and I wish you all the best with the rest of the conference. Thank you.